Alright, so we are going to talk about section 4.1, which is really going to be talking about sequences as functions. So we're going to be seeing what is the relationship between a sequence and a function. Functions are what we learned about in our last lesson. They're talking about having an input and an output, like y equals mx plus b form. Graphing something that has an input and an output, having an x and a y. Also function notation using f of x. That's all stuff we learned about functions. But we're going to look at sequences and see how do they relate to functions. So our essential question is, what are the key similarities and differences between sequences and functions? And just to vocab here, a sequence is all it is a list of numbers in a specific order. So that's very, very important to understand that they have an order to them. They have a specific order that they go in. There's something that's happening directly to each individual item in the sequence. So a term is each element in a sequence, and we'll see exactly what that means. Alright, so one sequence, I'm going to give you guys a couple sequence examples just to start us off. And one of the ones that we've seen since kindergarten is just counting whole numbers. So our first example is just going to be 1, 2, 3, 4, 5, 6, and so on. Okay, that is a perfect example of a sequence. It is a list of numbers, and they're in a specific order. What's happening? All right, I'm adding 1 each time, increasing by 1 each time. Cool. What about another one? We start learning this a little later. What about counting by 2s? 2, 4, 6, 8, 10, and so on. Okay, perfect. Another sequence. Maybe we want to multiply by 3 each time. So 3, 9, 27, etc. Multiplying by 3 each time. Okay, maybe we want to start at 100 and we want to count down from there. 100, 99, 98, 97, so on. Maybe we want to do this sequence, but every other one's a negative. So 1, negative 2, 3, negative 4, 5, negative 6. Anything like this, any of these are all sequence examples. Okay, and every single element in these sequences is a term. So in this example 1, the terms would be 1, 2, 3, 4, 5, and 6. All of those little pieces, all of those numbers are terms. So this should have been done on the right-hand side so far, but I want you to give me at least 2 sequence examples on the left-hand side. So you need 2 examples on the left-hand side. So go ahead and pause the video now and complete this on the left-hand side. Alright, so let's start looking at exactly why these sequences are somehow related to functions. So let's look at our sequence. We'll do our even numbers. 2, 4, 6, 8, 10, 12, and so on. Okay, we can keep counting forever, but we're just going to put those dots to represent and so on. And we're going to think about this sequence has a bunch of terms. And we're going to think, okay, 2 is our first term. 4 is our second term, our third term, our fourth term, our fifth term, our sixth term in the sequence. So if I were to ask you to find me the 4th term in the sequence, you would say, oh, that's 8. If I asked you to find the 6th term in the sequence, oh, that's 12. If I asked you to find the 100th term in the sequence, you would have to figure out what that 100th term is. Alright, so let's see how we could write this somehow in maybe function notation. Well, what we have here is we have 2 sets of numbers that coordinate with one another. So we're going to make something that looks sort of like an XY chart. This can be laid on its side. And we're going to see what happens here. Okay. So our X's are going to be our inputs, which are going to be the number term in the sequence. So if it's the first term, it's going to get a number 1. If it's the second term, it's going to get a number 2. If it's a third term, a number 3. Alright, so we'll just start with, this chart is only going to represent our first 6 terms and nothing after that. Okay, and our output, or our f of x for this first term is 2, because 2 is our first term from our sequence. Okay? For our second term, our output, or our value in the sequence, our term, is 4. And we can continue this on and fill in the whole chart and fill in the chart forever if we wanted, but this gives us a general idea of the pattern. So 6, 8, 10, 12. So there are inputs. Your inputs are what number term is it in the sequence? Is it the first term, the second term, the third term? And the output is the term in the sequence. So I want you guys to take this idea and use it on the sequences that you just made on the left-hand side. So what I want to see you do on the left-hand side is you just had 2 examples of sequences. You've already done these on the left-hand side. And I want you to make them into f of x charts. Okay, so this is what your left-hand side should look like. You should have 2 examples of sequences on the left-hand side. And you should fill in these XY charts. Awesome. Make sure you pause the video, get that done now. Alright, if you're back with me, I'm assuming you've already done that, making the tables on your left-hand side. We're going to look at one table here, different one than we looked at last time. And we're going to think about our function notation and how it applies to these sequences. So we'll look at first term, second term, third term, fourth term, fifth term. And by sequence, it's going to be a little bit different. We're not going to go even numbers now. We are going to go from 100. We're going to go down by 5s. 5, 90, 85, 80. And we could go so on and so forth, all the way down. If we wanted to, we could do a million different terms if we wanted to, but this is where I'm going to stop. So if we look at function notation from before, function notation is represented as f of x is equal to, and then you get some sort of output. Remember that whatever is in this parentheses is your x value or your input, and whatever is your output is your y value, whatever your answer is. So if I were to ask you, I'm going to erase the vocab for this. If I were to ask you to find f of 1, that 1 is your x value. So you're like, that 1 is my x value. So my output is 100. Okay? If I were to ask you to find f of 3, well, 3, that's my x. So my output is 90. Okay. If I were to write f of 6 is equal to 75, that means my 6th term is 75. Okay. One more we'll do. F of x is equal to 95. So this is your y value or your output. So your y value, your output. Okay, we find the 95 and we think, what's our x value that lines up with that? Well, x would be equal to 2. Okay, I'm going to give you some to try. I want you to use this exact same chart, but I want you to answer these function notations either right underneath or on the left-hand side, either way. I want you to find what f of 4 is, what f of 5 is, what f of 7 is, and then I want you to find the x value, and I tell you it's equal to 90, and the x value, when I tell you, is equal to 60. Alright, go ahead and answer those 5, either right underneath or on the left-hand side. Either way is fine. And we got one last thing that we want to look at. Okay, so I'm going to erase this now. last thing we're going to look at is we are going to do from XY chart to sequence. Alright, so I'm going to give you an XY chart here. We're going to see how that actually relates into a sequence. So X, f of X chart. Alright, let's do 1, 2, 3, 4. We'll do an easy one, then we'll do a hard one. Alright, here, so all I want you guys to do is go from this XY chart to writing the actual sequence of numbers. So here's a function, we're given an XY chart, here's a function, and I want you to write me the sequence of numbers. Okay, well the sequence of numbers is given right here as our output. So our first term is 6, our second term is -5, third term is 4, and so on. And we can just put the dots, dot, dots, for, and so on. Okay, what about a little bit harder one? So, let me give us some different X's and Y's. Okay, let's do... Alright, let's see what happens here. So we have, this is our last one we're going to do. And then I'm going to give you one to work on your own. So all I want here is you to write the sequence. So it gives us all of this information in XY chart, we got to write a sequence. Okay, well we know that the first number, the first term is 2. So let's jot that down. First term is 2. Awesome. Okay. But wait a second, it doesn't give us the second term. We don't know what the second term is. We only know what that third term is. Okay, so the third term is 8. Okay. The fourth term is 11. The fifth term, ooh, we don't know what that is either. Gotta leave it blank. Sixth term is 17. And the seventh term is 20. Okay, so let's see what's happening here. So we're thinking, alright, well, let's look at these numbers that are next to each other and see if we can see some sort of pattern that works out with these. So from 8 to 11, what could be happening? Well, like, they're not really like multiplying. It's not like 8 times 2. They don't really seem to relate to anything. So let's see how much we're adding each time. So to go from 8 to 11, I'm having to add 3. Alright. Well, let's see if that works for 17 and 20. Yeah, cool. We add 3 there. Alright, so let's see if it works. Let's see if we can fill in our blanks then with that. So if we add 3 right here, 2 plus 3, we're going to get 5. And does that work from 5 to 8? Oh, yeah, cool, it does. Right, so let's check it out. Let's see if it keeps working. If we add 3 to 11, we get 14. Okay? And if we add 3 to 14, we get 17. Awesome. So there is our sequence of numbers, remembering to put the dot, dot, dot at the end for and so on. There is our sequence of numbers that represents this function. So it is, sequences and functions are perfectly aligned, and it's really easy to go back and forth from one to the other. Alright, I'm going to give you one to try on your own. And all you are doing is you're going from the XY chart to a sequence of numbers, just like we just did right now. Okay. Alright, so check this out, see what you can do. I want you to write out your sequence of numbers. Make sure to do this one on the left-hand side. Go ahead and pause the video and complete that now.